Assalamu alaikum wa rahmatullahi wa barakatuh. This is Abdelrahman Omar, a graduate teaching assistant at AST Aswan campus. Today I'm gonna interview Mathew Picardal. He's a structural engineer YouTuber. We've been trying to make this interview for 3 or 4 months. So finally we did it, and enjoy watching. So today I'm going to interview Mathew Picardal. He's a structural engineer. I'm going to ask him about his structural experience and some tips for our students in Arab Academy for Science, Technology, and Maritime Transport, especially Aswan campus. We have a lot of campuses in for AST, so I would like to welcome you and thank you for accepting my invitation for this interview.
Yeah, no problem. It's my pleasure to be here.
Thank you. So Mathew is a structure project manager at DCI Engineers. He's a co-host of the Structural Engineering Channel podcast and a content creator. So can you tell me more about yourself?
Yeah, sure. I've been in the industry, the structural engineering industry for about 5.5 years right now. And yeah, I started on projects. I do buildings. In the US, there's bridges and buildings. They're kind of separate career paths. So for me, I do a lot of building design work. And I've got to do all sorts of buildings from concrete to post-tension, steel, wood, masonry. So I've been fortunate enough to be exposed to all sorts of different materials and projects too. And that kind of got me started going on, more interest in trying to give back to the community. And that's how I started my YouTube channel and even being
Yes.
a podcast host with Anthony Fasano on his podcast for the structural engineering field. So, that's how I kind of got started, and I was just doing it for fun. And it's been great to see how much positivity that it's giving back to the community.
Yeah.
And I think it's great because, when you see people, they they say that they saw your channel, or the students, they go up to me and they ask me like for career tips and what it's like. It's
Yeah.
For me, that's what's really cool, because someone did that for me in my career.
Ah.
When I was a student, I didn't really have guidance. So when I found someone that was willing to help me out, out of their own free time, that really got me. I wouldn't be in my career and be fortunate enough to be in my position professionally. So, that's kind of what got me started on doing this type of structural engineering content, because to help people out, and hopefully people can connect with it, and they get excited about structural engineering, or they see it and they realize it's not for them. That's fine too.
Yeah.
So yeah, that's kind of where I ended up right now. And like we were talking before, I just got done with my licensure exams. That one in the US, we have to do licensing. So that one was, uh, if you guys have been wondering where I've been, I've been studying for the past couple of months.
Yes.
But I just got done, and it's been a big relief. Felt good about it. So getting back to everybody, I feel like I've been like holed up in a cave. So
Ah, yes. So I will start asking you some questions that I think it will help our students to think about their future, their profession as a civil engineer or a structural engineers. So first of all, why did you choose civil engineering to be your profession, or structural engineering?
yeah, sure. So for me, it kind of sparked, if we were to go back, probably in my teenage years, I'd be watching those TV shows where they would show uh, buildings or bridges, and they would get into the engineering of it. That's kind of what sparked my interest, and seeing what problems there were. I remember, I think it was Taipei 101, just
Yeah.
why they needed to put that mass damper on top, and what a big problem that was, and how the engineers solved it. That's kind of what sparked it at a young age. So going into college, university, I picked civil engineering. I had structural engineering in the back of my head, but I also, for us, civil engineering was pretty broad. So we had geotech and like transportation
Yeah.
and land development, and so it was pretty broad. But I really had an interest in geotech and structural engineering. It wasn't until I did my senior project that I went all in structural engineering. Our project was design based, so we had a building and we were basically designing it like we would in the industry.
Yeah.
And that collaboration and using all of the knowledge that we learned in our studies to design something, that's what I really found interesting. I was like, okay, yes, this is the career that I want to pursue. This is the work that I really like. So getting my hands on in some practical projects, I was like, oh, this is what I really want to do, because it uh, using all of the stuff that we use in school, the strength of materials, the concrete classes, etc., and then working with the architect to create something that's going to last for who knows how many years, depending on how many years it is. That's something that was really fulfilling. So that's how I kind of got into structures, because using all the science to create something that's going to last for generations, and it helps people out, because that building, it's going to help the environment. It's people are using it in a good way, and it really creates an impact. So all that stuff coming together, that's why I really wanted to get into structures.
Yeah. Nice. So there are requirements for you to join engineering, or you just want to join it? You will do it in the US. So in Egypt, we have to have get a high score in high school. So that will lead you to join engineering. What about US?
Yeah, in the US, it's pretty much we go to high school, and then you hopefully you get good scores in high school so you can go to a good college or university. And once you're in the college or university, yeah, hopefully you go to a good one, and then that they're reputable in the engineering industry.
Yeah.
And that's where we pretty much start your career. You pick civil engineering as your major or your specialty, and then yeah, it's pretty much you pick it, and then you get accepted into it, and then you basically have 4 years to study it.
Yeah.
But yeah, that's pretty much the requirements. But if you're talking about professional, to be a professional engineer, then you have all the licenses. Um, if you want to get into that, I can go into that.
Okay. I'm with you.
Yeah, yeah. So just a real quick. So kind of what the career path is in the US, at least, is you go to university studying civil engineering, and then probably in your last 2 years of university, you take a fundamentals of engineering. That's kind of like your first license exam. So it's an 8-hour exam. It tests you on the basics of physics, strength of materials, etc. It's pretty broad. Like any engineer can take it, and that's just to get you your license to. It basically says that you're an engineer and that you're in training, and that's going to be your profession. And then once you graduate, you get your first job. You'll work for about a year or two, and then you can get your professional engineer license. And
Yeah.
that's when you can actually sign and stamp drawings legally. So that's pretty much where the career path ends for civil engineers. And once you get your PE license, you're good to go. Like that's the last license. For me, what I was talking about was the structural engineering license.
Yeah.
That's the license after your PE. It's a specialty license for your board exams. And for us in California, at least, it's not required throughout the US, but in specific states, basically where it's seismic for the most part,
Yeah.
like in California, uh, yeah, seismic, it's almost expected that we do get our SE license. That's our structural engineering license. That's after you've taken your professional licensure, you work for 3 years professionally under a structural engineer,
Yeah.
and then you can take it. And that one was a tough one. I just finished that. Yeah, 16 hours of of back-to-back exams, and yeah, easily 300 to 400 hours of studying. And it's a low pass rate too. I think it was about 25 to 30%
Yeah.
because you are graded by your peers. So I think that's the tough part about that license. It's not just a multiple choice like the others. There's a portion of it where you're doing an essay and you got to show your whole process. But I'm glad it's over. I
You
learned a
did
lot
well. Yeah, you
actually
did well.
studying for it. So that was a journey.
Yeah, thank you. So I've read that you've graduated from the University of California. Yes.
Yes, University of California, San Diego. Mm-hmm.
Yeah, I think it's one of the best universities all over the world. So how did your university affected your career professional?
Yeah, so University of California, San Diego. It was really great experience going there. I went there for my master's, and for me, I think I had a good path in terms of university and master's. So for my undergrad, I went to Cal Poly Pomona, and their philosophy is, really practical. So it was great
Yeah.
because it's kind of like a trade school for engineers.
Mhm.
Less theory, more of what you're going to be doing on the industry. So I got that during my undergrad, which was great. But then going to UC San Diego, that really filled in the theoretical gaps that I had,
Yeah.
because UC San Diego, more research based. Obviously, they had those big shake tables, which were really cool, and the professors that were working on those too, telling us about the research. And what I really learned a lot about was why the codes are why they are,
Yeah.
like tests that they're doing, and even performance-based design, non-linearity in materials, and seismic design. I think that's the really big thing that we learned, the seismic design that we don't really get in our undergrad classes. So in overall big picture, it really filled in the gaps because I was really practical before, but now I have the theory that goes into, all of the programs that we use in the industry. It's a really good to understand those concepts like finite element, nonlinearity, because our programs do it. So it's nice to know kind of what the procedures are for what the program is doing and why the codes are why they are.
Yeah. Yeah. So how did you make use of your vacations during your studies?
So when I was studying, I've always tried to get internships or working at a firm, and even during it took me about I had a short master's, so it was about a year and a half of my master's program, and during the summer of that,
Yeah.
I worked for a structural engineering firm as an intern. So for me, it was always at least in the US, and I'm sure everywhere else, you need to get that work experience because, it is competitive. So uh, the more internships you have, and the more experience that you have, especially with structural engineering firms, the easier it's going to be to find that position, after you graduate, if you want to work in the industry.
Yeah.
So
Okay.
always try to get
To make
work
use of it.
experience.
Yeah.
Mhm. For
Okay.
sure.
So after graduation, how did you think about your career after that? Did you wanted to make your master degree or practical trainings, or you just wanna work? How did you think about it?
Yeah, so after graduation, I knew I wanted to work in buildings and in the private industry. Throughout my internships, I got to see what it was like in the public sector and the private sector, or government and private.
Mm.
And I knew there was more design work in private. That was the main reason I wanted to join a private engineering firm, because that's where all the design work. We get to design buildings, we get to see them built. So for me, that was always my career goal, to work in a firm like where I am now. So I just tailored my internships towards that. So I would apply to these structural engineering firms so that I could eventually work in the private industry.
Okay, very good. So did did you get your master degree? You've got your
Yeah,
master.
yeah. Yeah, so kind of bigger picture with that, it's in California, it's seismic. So a master's degree is almost a requirement in the seismic zones in the States.
Yes.
So if you want, that's why I wanted to get my master's because, after I knew I wanted to get into structural engineering, I realized that the industry was, it's almost a norm in California to get your master's because that's where you learn all of your seismic philosophy that you're going to be using on the
Yes.
job. So yeah, it was part of my bigger plan. It was, um, uh, and I was kind of late too. So, it was like my third or fourth year. I wanted to do structural engineering, and I applied too late to my master's. So again, I had a year off, but I used that year off after I graduated to intern for the city and for a structural engineering firm also. So always building that experience. Then I went to my master's and then getting more experience and then graduating to get that structural engineering position that I've always wanted. So yeah, it was built in, but my master's was kind of a requirement just because where I'm living in
Yeah.
seismic
Yes.
zones, it's pretty much a requirement if you wanted to work for a reputable firm.
So it was about seismic, just seismic, or a specific thing in seismic. So what was the point of the research?
Yes. So for me, yeah, it was a lot of it was seismic. That's kind of the reason why I chose UC San Diego also, because they when I was looking for uh, my master's programs that I was applying to, it was all about seismic. I knew I wanted to learn more about seismic, so I looked up the best structural engineering schools that specialized in earthquakes and earthquake design, seismic design.
Okay, yeah.
So for me, I really had an interest in that, and that was really interesting too. Just learning about
Uh,
all those philosophies and performance-based design. So yeah, it was great.
so what do you work now? What is DCI Engineers that you work in right now?
Yes. So DCI Engineers, we are a mid to large size firm, and we specialize in building design. So, we have a couple hundred employees here in the States, and a lot of us, we have a small office, but a lot of employees spread out throughout the States. But yes, we do a lot of building design. So it's not in terms of we're not doing like research based stuff. For us, we're designing buildings. So we're using the codes, we're using software, we're sketching up plans and drawings and getting them ready so the contractors can build it. So
Yeah.
for us, that's what we're doing, and that's the type of work that I like doing, like
So
designing and stuff on
you're
drawings.
just a designer. You're not working in site, in field.
Yes. So yeah, for us, we'll do site visits, but we basically work from in the office most of the time.
Yeah.
And whenever they need a structural engineer on site, they'll give us a call and then we'll do a site observation. So we're not the field engineer that's on there on site. The contractors usually have project engineers on site, but the type of work that we typically do, we basically go onto the field when the contractor calls us, but it depends on the project because there are some projects where they want the structural engineer on site all the time.
Yeah.
And that's kind of more of a special case and the type of projects that you work on. But that has happened where we have engineers basically go work with the contractor and they're on site like 90% of the time. So it kind of depends. But the type of projects I do, yeah, mostly in the office.
So what are the most challenging project you have ever been involved in?
For me, I would say there's been a lot. One that pops up into my head is um, a religious facility, pretty much a church. And it was what makes them challenging is that they're custom. And I think that's what makes a project challenging because this one was, everything was custom. I think that's what makes it challenging, and figuring out the lateral system for it. Because if you have a simple building, you kind of already know what the systems are going to be. So we can just, copy and paste our typical details for our typical buildings. But then when
Yes.
you have something custom, a stepping roof, 40, 50 foot tall walls, and everything's really custom, and they have like really custom overhangs. That's what makes it fun, but also challenging because, okay, how are we going to do this? Is this the most cost efficient way to do it? Should we use steel? Should we use concrete? How are we going to take into account these 100-foot spans? How do you span 100 feet? What's the best system to do
Yeah.
that? And for us, we ended up using trusses and buckling restrained braces for the lateral system. And yeah, getting all the parameters to work, like even with the drifts and the
Yes.
lateral requirements, is that enough for it to meet the code requirements? And yeah, we ended up doing like huge custom trusses and for the roof stepping and whatnot, and the overhangs. But it was a fun project, but it was definitely challenging because each portion that you got into was like a unique problem. Oh, we
Yes.
got this. Well, how does that integrate with the whole
You didn't do
system?
it before.
Yeah, I haven't done that type of work before because it's like a custom church, kind of like a custom house or a custom project where nothing's
Where
cookie
is it?
cutter.
Where is it? We can search for it on Google.
Yeah, this is in Santa Ana in California,
Okay.
and they're still building it, so it's not complete yet, but they're in the process of completing it. So that's one of the projects that was really cool to work on because it even had like a pile foundation system. So it had a
Yes.
lot of stuff. It was a fun project.
Okay. So as a designer, what are those softwares that you are working with?
Yeah, as a building designer, we use a lot of different softwares, uh, but for the most part, like I can give you like a basic rundown. So if we have a concrete structure, concrete tower, or building, we use ETABS for the lateral analysis. I know there's um, for the lateral analysis, and for the slabs and gravity, we use RAM concept. So we split it up. I know there's some firms that try to use ETABS and everything, but for us, we found, I guess, more efficient or better software that we like to use for like slab design.
Yeah.
So yeah, ETABS, we use ETABS for the concrete shear walls, and we use it with SP column to get to the PM interaction. So
Yeah.
those are the two softwares mainly for concrete, and we use RAM concept for the slab design. For steel, we use RAM structural system.
Yeah.
It's basically a software where you can model all of the steel members. And that one, if it's like all steel, we'll use it for gravity design and also the lateral design because it does moment frames, brace frames also. So for steel projects, we tend to use that. And of course, we have a lot of different programs too, like we'll get the forces in these programs and then export them to a detailer, like ramp connection, for example. That designs the bolts, that designs the shear
The
tabs for the
connections. Yeah.
steel. Yeah, so different programs for connections and anchor bolts too. And then we also have, well, we still use spreadsheets. So for wood, it's hard to model that, or difficult to model that in finite element software, just because wood's kind of weird like that. It's so many pieces, but we use spreadsheets for wood. So for our wood design, we still use Excel spreadsheets. They're more advanced, but for the most part, we're still using Excel. We're still using, I like to use MathCAD for my calculations for hand calcs. And yeah, there's just a lot of softwares that we use, but those are our main ones if you're talking about concrete and steel.
Yeah.
But there's so many in the industry. So, that's not like, I know a lot of firms that use different types of software, but I think ETABS is probably the most popular one.
Okay, so you don't utilize BIM softwares in your firm?
Yes, we do use BIM software, but for our firm, we have it split where we have the engineers working on the engineering software, and then we have our designers or drafters that specialize in Revit and BIM and making the actual drawings, the contract documents. It's not like that with every firm, but the way our firm has it set up, yes, we have engineers separate from the designers or the
Drafters,
BIM specialists. Mhm.
yes, yes.
And yeah, depends on the project. We still have BIM. Like we always have a 3D, almost always have a 3D model from the architect or whatnot, and then we create our 3D model as well. So for sure, Revit is mandatory.
Yes, yes.
We use it every
So
day.
how did you learn how to use Revit in your college or after graduation?
I learned it while I was during college. So for our senior project, I learned it on my own. It wasn't mandatory, but I saw where the industry was going, and yeah, I just learned it by myself, took some tutorials, found some classes. So that's how I got started in Revit. And after I graduated and started working, I use it a lot less now. Like I use it for viewing and modifying stuff, but my end goal isn't the final drawings for that. So I know how to use it and move around it, but I'm not a specialist in it, at my point in my
Because
career.
we teach our students how to use Revit. It's a requirements for graduation.
Oh, that's great.
Uh,
Yeah.
yeah, it's very important software in today's work.
Yeah, for sure.
Okay, so you don't use BIM as a specialist, but how it affected the construction industry, the BIM, how it affected the construction industry?
Oh, yeah, it's affected it a lot because now, for the most part, almost everyone has a 3D model. Not
Yes,
everyone, but for the most part, it's pretty common that all the disciplines have a 3D model. And what's really cool about that is depending on the project, sometimes we can, make a Revit model, export it to our structural analysis software. That's really cool. But I find most of the time we're using it for coordination because the architect is showing some weird, complicated structure. You're trying to read it on 2D plans. You don't know what it exactly means. But if you have something in 3 dimensions, it's so much easier. And coordination with mechanical, electrical, and plumbing, uh, that's what's really crucial because that saves a lot of headaches on the field when you're clashing with plumbing or you're clashing with mechanical
yes.
units because something's in the way. So having all of that in one 3D model, I think that's what's really cool about it because that saves so much time and headaches out in the field, and it's a really great coordination tool for all of the engineering team and the
The
contractors.
partners, yes, yes. So
Yep.
your YouTube channel, what is the main purpose of it? What is the content you want to deliver to your audience?
Yes. So for my channel, it's a structural engineering channel, and that's kind of my outlet for just showing what I've gone through. I'm not a career advisor or anything like that. I'm just I'm working out in the profession that I really like working in. And I know there's a lot of students, a lot of young engineers that want to get into it or know what it's like. So that was the purpose of my channel, to show what structural engineering is, a career in structural engineering, what it takes to get into it, the pitfalls, the challenges that you'll face, and show you the ways that I got through it. Because I know there's people taking, like the licensure thing, that's a big thing that engineers go through in the US. And I show them how I did it. I'm not an expert, but these are the challenges that I'm facing. These are the failures and the mistakes that I've made throughout my career. And hopefully you can learn from it and get you interested in the field. And yeah, that's pretty much been the goal of my channel, to
You're making
educate
your own
people about the
community.
industry. Yes, exactly.
Yes. Okay. So I've made a post on my Facebook asking my students what are the questions you want to ask you about it. So
Yeah, that's cool. Yeah.
can I ask you their questions?
Yeah, sure.
Okay. So the first one asked, he's a fresh graduate and he passionate to be a structural engineer. So should he work as a structural design engineer from the beginning or of his career, or it's preferable to work as a site engineer in the beginning till he gains enough experience in execution different structures that make his designs more reliable?
Yeah, that's a good question, and I'll give you my perspective from the U.S. industry, since obviously that's what I know. For people, I tell students if they can get an internship in the construction field, like from a contractor where they're out in the field, I think that's great because um, that's kind of some of the weaknesses of new engineers. They've never been on site. They don't know how stuff is constructed. They don't know what's practical. So if you can get that during your internship at a construction firm, that I think that might even be better than an engineering firm, because that shores up what your one of your weaknesses. But let's say if you graduate and you find yourself in a construction firm, it's still a good move. So if your end goal is to be a structural engineer, in the U.S., um, I like to look at it as if you've been in the construction industry. So you graduate and you go to a contracting or construction firm, you work there for 1 or 2 years, and you're still getting some of the technical knowledge. So you can still be a project engineer on site. So that means you can still get your professional license.
Yes.
So if you're 1 or 2 years in the construction industry and you're still an engineer, it's easy to switch to structural engineering. Uh, I say 1 or 2 years because if you've been in the construction industry for 5 or 10 years, for the most part, we think, or at least my perspective is that you're going to be rusty on your engineering skills. And it
Yes.
might be tough to transition into the structural engineering design field if you've been in the construction industry for so long. So for me, for sure, it's great if you can get it during your internship or even work 1 or 2 years in the construction industry. But if your end goal is to get into structural engineering, transition early as you can, because it might be tough the longer you're out of it.
Yes. Yes. Okay. He's asking his second question. Do you work on global RFEM software for wooden
Global,
structures?
I think I've heard of that software before. We typically don't use it, but like I said, there's just so many softwares out there, and I know a lot of students are asking that question because they want to know what software they're going to use. But in reality, you're not going to know until you join a firm, because all the firms have
Yes.
different softwares. And what I tell them is, learn one software, learn it well, learn ETABS. And once you learn that software and obviously know your basics, concrete, steel, know the basics. But once you figure out one software, you can figure out all the other softwares. I mean,
Yes.
you haven't not hired someone because they didn't know a software. It's like, okay, ETABS. Well, we know you can learn this other software because it's just software. And we're not hiring you to be a technician. We're hiring you to be an engineer to interpret what the software is outputting. So I know don't focus too much on the software. Know the fundamentals, and once you learn one, you can learn anything.
Because his senior project was about wooden structures, so he's asking this question. So
Yeah.
the third question, do you think if he started in preparing for his master degree in structures from now, will it serve his career track or it just serves his academic track to work in academic fields only?
So the question was about if they should pursue their masters.
Yes.
Yes. So I think it depends on what your end goal is and where you want to work. For For me, like I said, getting my master's was kind of twofold. I wanted to get work in the industry, and it was kind of a requirement where I'm at. But I also wanted to learn more about seismic. So for me, it was both professional and curiosity about seismic. If if your end goal is academia, I think for sure
It's a
that's like the first
requirement, yeah.
step. Yes. So I think, and it depends on the industry too, because like I said, it was a requirement where I'm at, but it's not a requirement in some other states where they don't have seismic. So trying to find out where you want to work, what type of buildings you want to work on. If you want to work for like a global company, I say it's a safe bet because if you're going to work anywhere can have seismic. So you want to have that seismic background with
Yes.
you. But yeah, for me, it depends on where you want to go, but for me, it was a good choice because I did want to work on seismic projects.
Okay. The fourth question, will the FE certificate optimize my CV, and should I start in preparing for it from now?
For the FE, the fundamentals of engineering, that's the that's the exam that you typically take when you're a student, if I'm correct. But yeah, for sure, we always encourage U.S. students to take their FE exam during their last year of college. Basically, we want them to get it before they graduate. So for sure, because it looks good when you have it and you're going for for an interview. It shows that you've already passed that first step of licensure. So it always looks good when you pass it.
Okay. So the last one, I think, what are the best universities there? He means in US for preparing his master degree in structural engineering. So and has interests in green structures points. So
And green structures. So I'm not too sure about green structures since that wasn't my focus when I was applying. Uh, so I can just start naming some schools off. But again, these were seismic focused, and there's a lot of other ones. But the ones I applied for, I know for sure UC Berkeley is definitely one of the top ones. UC San Diego, Stanford, University of Illinois, Urbana-Champaign. That one's a really good school, famous school. Uh, I also applied to, what was it? The University of Buffalo, because they had a really good earthquake seismic program.
yeah.
Again, I was all seismic, so that one. I know the University of Reno. Uh, that one was a good seismic one too. I also applied to Texas A&M and um, oh, there was another one. It was another UC school, but it's slipping my mind right now. But those were the schools that I applied for. Of course, there's others I know like UCLA, USC. There's yeah, those are the things that are coming off the top of my head. But I know there's a lot of good schools, but those are the ones
Yes.
that I know of.
Okay. I think the last question was how to earn money quickly from engineering. Do I have to work as a freelancer or what to do?
Yeah, if your end goal, or not end goal, but if that's one of the things that you eventually want to make money off of, the paths to getting that raise. Uh, yeah, so just to be clear, if you want to be like a multimillionaire, you're not going to get that by working a regular job, right?
Yes.
So if you want to make money, the high risk, high reward is starting your own business, right?
Yes.
So that's pretty much the way it goes. Like for me, if you're talking about, let's just start from the bottom. You graduate, you want to make money, and you're working for a structural engineering firm. That's what I recommend because I don't know where this student is, but if you try to just freelance off the top of your head, you need industry experience. So for sure, I think everyone should start off as an employee working in the field, because you need that experience wherever you're working at. You need that industry experience. And let's say you want to make more money. There's a couple ways to go about it. Either get promoted in your company and ask for a raise. And there's different tactics to that too. But that's one way to go about it. Get promoted in your company, or change jobs, go to a bigger company where they offer you more money. Or like this person was suggesting, maybe start your own firm or your freelancing business. And this is my opinion. I think starting your own firm is great, but it's going to be tough.
Yes.
It's going to be tough because a lot of us don't have business degrees, right? We're engineers.
Yes. Yeah.
And a lot of engineers
make a business plan for yourself, so it's hard for you to be in the top 10, I think.
Yeah, business plan and even the business acumen. A lot of engineers think that they've worked in the field. Oh, I know engineering. Let me start my own business. I can just make more money because I know engineering. Well, it's a whole different ball game. And then what their business strategy is, oh, I can't get clients, so let me lower my price. And so what ends up happening is they offer their structural engineering services that they've honed for like decades and years studying this, and their business strategy is let me lower my value. And it's not good for the industry because that's what the owners, the contractors, architects see what our price is now. Well, this engineer is offering a lower price. Why are you as an engineering firm, why is it so expensive? So it kind of becomes the norm. It keeps lowering the bar. So if you don't have that acumen, that business acumen, I would suggest not starting the firm because it lowers the value of the whole industry. And that's why you get people complaining about our industry. Why do we get paid for it so low? Because yada, yada, yada. Well, it's our fault, as an industry. But yeah, my ideal case is, learn as much as you can and from your company, and, get promoted in your company. At least that's my route, doing as much as I can for my company and learning as much as I can from my company. And hopefully I can grow with my company and, get promoted and do bigger things in my company also. So that was my route. And yeah, just a quick tip if you're trying to get promoted in your company and whatnot, document all of your wins and talk to your manager a lot, because you kind of have to learn how to market yourself too in your own firm. A lot of employees think that I'm doing all this work, why aren't they promoting me? Well, they don't see the work that you're doing, and you're too afraid to market yourself to show how all the work that you're doing in a presentable way. Because again, from the business acumen perspective, someone has to approve that raise. Someone has to approve that promotion. And the better you can communicate to your managers, to your bosses, to the company, the value that you bring as an employee, the easier it is to get a raise. And that's something that I learned.
Yeah, okay. So the last thing I want to do is to give advice for undergrad students. Something they have to do before graduating, because they are wasting their time. They don't do what they have to do. What are these advices that you want to say to them?
Yes. So from the US industry, and when we're hiring new engineers and interns, it's so important to have work experience, internship experience, because that kind of vets you out. And if a student's asking me, what should I focus on? If I go have an internship, my GPA is going to get lowered, right? And I would tell them, get the experience, even though your GPA drops a little bit, because that experience is going to make up for that. It makes your resume that much more stronger if you've worked for an engineering firm. And because it'll give you industry experience, but it'll also give you references. So if we need to find someone to vet you out. We can just call your old firm to see how you were. If you don't have that and all you have is a GPA, that's great, but no one's like tested you before. You're not industry tested. Like, can you work with people? It's a big question mark. We're taking a risk as a company. But if you've already been tested out by a lot of other companies and you have that experience, it makes you that much more reliable, you know, from a resume point of view. So that's one thing I definitely recommend. Try to get as much industry experience as you can while you're still in school, because it's a differentiator. Like, if you give me a 4.0 GPA and someone with industry experience and a 3.5 GPA, we'll want to get the one with experience, because yeah. And just to give you a perspective on that internship experience, it's training. It saves the company money because you've already been trained for 3 months or a summer, and that's money. As a company, we don't have to train you. So that's why it makes so much sense from a company perspective. Someone's already trained you, and we don't have to spend that much time training you.
You know the work already. Yeah.
Yep, exactly.
Okay. That was my last question. So it's a pleasure to have you with me. I didn't think that I can invite you for such an interview. So thank you for your advice, and okay, that's it.
Yeah, no problem. Thanks for inviting me. And yeah, you know, I always like doing these types of things because, you know, it does help the students out. So thanks for inviting me, and it's my pleasure. And yeah, if you ever need more questions, feel free to send me an email or LinkedIn chat.
Yes, thank you very much.